algebra students. Mr. Lawrence here. I'm frustrated, Mr. Lawrence, because I got to redo the video. You don't know this, unless your name is William Brown, but I had to redo the video. William was watching. He was laughing at me. It wasn't very nice, William. I don't appreciate it. Anyway, yeah, we had some microphone trouble, and the sound didn't come through, but we should be good to go now. William did a sound check for me, and he says everything is good. So, anyway, while you're at home enjoying the sunshine on Friday afternoon at 3:30, I'm recording videos. You don't believe me, just look down here. Okay. Today we're going to be translating and solving equations. Now look, read problem number 1. 1 more than 3 times a number. It's 13. What is the number? I know most of you are so smart, you can just figure this out. But remember, it's not about the why. It's about the how. Excuse me, I said that backwards. It's not just about getting the answer. It's about why. You got to be able to take this and translate it into an algebraic equation, because many problems aren't going to be this simple. Okay, so before we actually get to the translating solving, and actually this stuff is really pretty simple, but we want to review like 1 or 2 things first here. Oops, I lost my page. Where did it go? My page is missing. Hold on 1 second. Okay, I found the page I was looking for, and I wanted to review some keywords. Now, there'll be other keywords we'll pick up along the way, but these are some of the ones we start with. And the first one is sum. We should all know that the sum is the answer to an addition problem. And of course, difference is the answer to a subtraction problem. Product is the answer to a multiplication problem. This should be reviewed. This should be like elementary school level stuff. Quotient should be the answer to a division problem, although you don't often see me use a division symbol. In certain situations, I will usually see me do a fraction bar, of course. Is, of course, means equal. Now, the real important ones here are less and more. If you hear something like 5 less than a number, it doesn't mean what you think it does. Okay, or it may not, I should say. Some of you, some of you smart guys out there and smart ladies probably know what it means, but some of you are going to get it wrong because you're not stopping to think. Let's make it real simple, because I know you can do this. Let's play a little game. I'm going to name a number, and you give me 5 less than that number. So I'll name a number, and you give me 5 less than a number. For example, I might say 10. Well, 5 less than 10 is 5, right? How do we get there? We subtracted 5. How about 37? 5 less than that would be 32. Sorry, I forgot my equal sign. How do we get there? We subtracted 5. So when you see less, you want to subtract 5 from both sides. Okay? When you see more, you want to add. If it says 3 more than a number, you're going to add 3 to both sides. Now, in addition, it's not as big of a deal. Oh, excuse me, not to both sides, to whatever it is we're taking more or less of. The point is, it's not 5 minus, which is some of you think. If it's 5 less, it's minus 5. 7 less would be minus 7. Now, with the addition, it's not as big of a deal. Like if you had 5 and then you wanted to add 3, or if you wrote 3 plus 5, you'd get the same answer, wouldn't you? These are equal to each other. That's because addition and multiplication are both commutative. Commutative. That's a very important property. You'll hear it mentioned more and more in the upcoming days. Commutative property of addition or multiplication. Commute means to go back and forth, like your mom or dad might commute to work. That means they leave their house and they drive to work, and then they drive back at the end of the workday. Okay, so you can say that 4 times 3 is the same as 3 times 4. It's commutative. Okay, you could even do it with a big problem like 10 times 2 times 1 times 5. That's the same as 2 times 1 times 5 times 10. The commutative property. Okay, now, by the way, commutative property does not apply to subtraction or division. I mean, look, 8 divided by 2, is that the same as 2 divided by 8? Of course not. This one equals 4, but that one equals 1/4. Not the same number at all. So you don't get the same thing. Okay? Subtraction, same way. 5 minus 3 does not equal 3 minus 5. If you change the order, you have to move the sign with it, right? So commutative property only applies to addition and multiplication. All right, let's get on to the problem here. Let's start translating. It says 1 more. Well, that means plus 1. then 3 times a number. Do I know that number? No, I don't. And that's the cool thing about math. If you don't know the number, you can use a variable. Now I need 3 times that number. Okay, is equal, and then 13. Watch this. I've got my equation. I start with the number. I need 3 times that number. One more than that, I have to add 1, is 13, and I'm ready to solve. So I'm going to subtract 1 from both sides. 3x will equal 12, and x will equal 4. Okay, now we can check our answer. We can go 3 times 4 plus 1. 3 times 4 is 12, plus 1 is 13, and look at that. That's what it's supposed to equal, isn't it? 13. So I know I did it correctly. All right, let's look at this one here. 5 less. Well, that's minus 5. 4 times a number. Do I know the number? No, I don't. 4 times that number is 15. So I have a 4x. Well, I'm sorry, let me start that over. I start with my variable. I need 4 times that variable. Then I need 5 less than that amount. Is 15. I'm ready to solve. It's just a 2-step equation. And 4x is going to equal 20. Divide by 4. Divide by 4. X is going to equal 5. And there you go. And if I check it, 4 times 5 minus 5. 4 times 5 is 20. 20 minus 5, 15. Yep, it checks. All right, here's another one. 4 more, so that would be plus 4. Then the quotient, that means to divide, of a number and 3. When you see it listed this way, you got to know which way to divide by because division is not commutative. You go in order. So I need the quotient of a number and 3. Now I need actually 4 more than that, and that's going to equal 12. All right, ready to solve. See how I did that though? Started with the variable. I need the quotient of the number and the variable. Had the problem said the quotient of 3 and a number, it would have been like this. Okay, but it didn't. It said a number and 3, so I went in order. So I'm going to subtract 4 to solve this. I get x over 3. That's going to equal 8. I've got a fraction there. Don't panic. Undo your fraction by multiplying. X is going to equal 24. Now, if you wanted to check it, you could put 24 right here. 24 divided by 3 is 8. 8 plus 4, sure enough, it's 12. And look at that, there's a 12 right there. So it does check. Okay, one more example, and then we'll let you go. That'll be the weekend video. All right, 1 less. I need to subtract 1 at some point. Then the quotient of x and 5. Well, that's x over 5 is 8. So I have x over 5. Take away 1, because I need 1 less than that. Going to equal 8. And I'm ready to solve. Oh, I don't want to use those two colors together. That might be a little bit yucky. I wouldn't want to gross anybody out. Okay, I'm going to add 1. I'm going to get x over 5. That's going to equal 9. Now to undo my fraction, I'll use multiplication because a fraction implies division, right? So the 5's cancel. Almost x equals 45. Checking my answer, I get 45 divided by 5 minus 1. Well, 45 divided by 5 is 9. 9 minus 1, 8. 8! 8 is great. And there it is. Okay, remember that when you're reading these, you got to go slow. Start with a variable when you go to write your equation. And remember, 5 less means minus 5. 12 less means minus 12. 20 more means plus 20. Okay, you do it kind of the opposite the way it's read. All right, that's it for the lesson. Mr. Lawrence signing off. Good night, everybody.